So today we're talking about 10.4, which is modeling quadratic functions. Modeling quadratic functions. So we're going to start off as talking about the differences between linear and quadratic functions. So if we look at linear are always going to be in the form of y equals mx plus b. Quadratics are always going to have an x squared, and they're going to look like a parabola. Linear, they look like a line. Quadratics, they look like a parabola. So if we go down to these problems down below, identify the equation as linear or quadratic. So there's no x squared, so this is linear. The next one for b, there is an x squared, so this is quadratic. Next one, there's an x squared, quadratic. Next one, there's no x squared, so this is linear. Now we're going to take a look at the table of values. We can find out if the graphs are linear or quadratic by comparing just the first and second differences. So I'm going to take this and I'm going to plug this in. So these are my x values, which means I'm going to plug them right into my equation. So if I plug in a negative 2 there, I get 3 times negative 2 minus 2. 3 times negative 2 is negative 6 minus 2 is negative 8. 3 times negative 1 is negative 3 minus 2 makes negative 5. 3 times 0 is 0. Minus 2 is negative 2. 3 times 1 is 1. Minus 2 is 1. 3 times 2 is 6. Minus 2 is 4. So fill in my chart first. Then I'm going to look at what's the difference. So notice there's a little hash mark here because there's no difference. There's nothing to do with. So if I go from here to here, how do I get from there to there? I'm going to go up 3. Here to here, 3. Here to here, 3. Here to here, 3. If I get them all to be the same, I don't have to do second difference. So I can just put this all the way through. Knowing that they're all the same, that means it's going to be linear, which we already knew it was linear based on the equation. But another way to check if something's linear is to look at the first difference. So we go to the next one. We know this is quadratic, so we're going to go ahead and put it quadratic. So let's go and see why it's quadratic. Okay? Just looking at the table. So I'm going to plug in a negative 2. So 3 times negative 2 squared. So negative 2 squared is 4. Times 3 is 12. Minus 2 is 10. Negative 1 squared is 1. Times 3 is 3, minus 2 is 1. 0 squared is 0, times 3 is 0, minus 2 is negative 2. 1 squared is 1, times 3 is 3, minus 2 is 1. 2 squared is 4, times 3 is 12, minus 2 is 10. So same thing here, no difference there. Go to here. How do we get from here to here? We go down 9. How do we get from there to there? We go down 3. How do we get from here to here? We go up 3. How do we get from here to here? We go up 9. Now, there's nothing to do there. There's nothing to do there because we didn't have anything up there, so we go here. How do we get from there to there? Up 6. Here to here, up 6. Here to here, up 6. So basically, how you know if you're using a table and not an equation, if something is linear, how do we know that? Our first difference is the same, as we saw from 2a. How do we know if it's our quadratic? Our second difference is the same. That's how you determine whether it's a linear or quadratic if you're only given a table, because you're not always going to be given the function like that. So if we go over to this table, we go up to number 4, and we're going to go up to this table, and we look at, okay, we need to determine whether this is linear or quadratic, because that's what it's asking us. It wants to actually know, is it quadratic? Yes or no? So, don't have a difference there. Go to the first one. Get from 2 to 8. up 6. 8 to 18, up 10. 18 to 32, up 14. 32 to 50, up 18. No difference there, no difference there. 6 to 10, 4. 10 to 14, 4. 14 to 18, 4. So is our second difference the same? Yes, it is. So the function is quadratic because the second difference is the same. And that's all that's to it. You look at the differences. So now let's go to the next one. So how do we get from 2 to 7? Up 5. 7 to 12, up 5. 12 to 17, up 5. 17 to 22, up 5. Do we even need to do a second difference? No, we don't. What do we know this is? It's not quadratic, so the function is not quadratic because the first difference is the same. What does that make it? Makes it linear. So making it linear. So now, the next part that we're going to be dealing with is actually writing a quadratic function based on a table. So we're going to go and we're going to do exactly what it says here. It says, use a graphing calculator to find the quadratic regression of the given data. Mode, to make sure stats diagnostic is on. So first we're going to go to mode. Let me turn mine on. Go to mode. Now for my calculator, I don't have a stat diagnostic, but usually it'll have a stat diagnostic. I'm using an older calculator, so it doesn't have that. You're going to have to make sure on yours that you go to stat diagnostic is on. And it's very easy. It'll show you, and it should say on. Once you've done that, as it says next, so first of all, we went to mode, make sure that is on. Then we're going to go to stat, which is right here. So we go to stat, and we choose one, which is edit, and you should get a list like this. And I want to enter this data right here. So time are our x values, area. So it takes us into the list. So I'm going to go ahead and type in, like I said, this is our x values. So these are what we're going to put. This is going to be for L1. This is L2. So I'm going to put in a 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter. Go over to the next list. Now, if you have things already in your list, a way to get rid of them is you use the arrow, you go up to the top, you say clear, and enter. And it should clear that list for you. If it doesn't, then you're doing something wrong, but it should clear the list for you. So now we're going to do our list too. So 9.0, 35.8, 79.8, 145.2, 225.1, 319.1. Enter. I've just entered all my data. Now, next, it says to hit stats again. So I hit stat again. It says to go over to calculator or calculate, go up to there. And I want to go to 5, which is quadratic regression. So I hit stats again, arrow to calc, and hit 5. So I hit 5, quadratic regression. Then I select it. So I'm going to hit enter. And look, it's going to give me my quadratic function. So notice that's a standard form of the quadratic function. This is our A value, our B value, and our C value. Now we're going to go to 2 significant figures. So 4 significant figures. So we're going to do everything in 4 significant figures. Doesn't say that, but we're going to use 4 significant figures. So when I write it, I'm going to get 8.564 x squared plus 2.444 x minus 2.780. Now, my calculator doesn't show an r squared value, but yours should if you're using the graphing calculators from the classroom. Mine's an older version. So you should see an r squared value of 0.9999. Now, what does that mean? The closer that value is to 1, the more precise your answer is. Precise your answer. So you should have gotten an r-squared value of 0.9999. The closer it is to 1, the more precise the answer is. So it's very close, which means that's pretty much the equation. If I was to graph that on my graphing calculator, these points should all be on that graph. So now we're going to go to the next one. So we're going to do just like what we did just a minute ago. We're going to go to Stat, Edit. So we did 1. I'm going to clear my list. Go up to my other list, clear it, enter. Then I'm going to enter in again. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Go over to list 2. 7.1, 13.8, 20.1, 29.3, 50.1, 62.3, 86.9. Then I'm going to go to Stats again, Calc, Quadratic Regression, which is 5, enter, and now I get my new equation. So if I write it, so y equals 1.693x squared plus, or actually minus because b is negative, so I'm going to change that to minus to make it a little bit easier, minus 0.4571x plus 6.486. And your r value you should get, r-squared value you should get there is 0.9946. Is that close to 1? Yes, it is. It's not quite as close as the last one, but it's still close to 1, which means that's a pretty precise answer. And that's how you find it when you're given a table, how you can find the equation for that quadratic. Okay, so your homework tonight is an HRW. You're going to have plenty of time to finish it before the end of class and to turn it into your folder. I'll see you guys on Monday.